Good afternoon, everyone, and welcome to today's webinar on fire protection systems for data centers. My name is Martin Franke, and I'll be your moderator for this session. As we all know, data centers are the backbone of modern digital infrastructure. With the increasing density of equipment, the rising energy demands, and the ever-present need for operational continuity, fire protection has become an essential priority for data center design and operation. Today, we will be exploring the different fire protection systems. I'm delighted that we have with us Chris Downing of the Euralarm extinguishing section, an expert in the field of mission-critical fire protection solutions. He will walk us through key considerations, common pitfalls, and best practices for keeping mission-critical facilities safe and compliant. Also with us, and I'm more than happy to announce him, is Peter Mita. Peter is president of Euralarm, and he will briefly introduce our association before the webinar starts. Throughout the session, feel free to submit your questions using the Q&A or the chat, and we will address as many as possible during the Q&A at the end of this webinar. We are excited to have you with us, and we hope that you will find today's insights valuable. With that, let's get started. Peter, the floor is yours.
Thank you very much, Martin, and welcome everyone to this important webinar on fire protection systems for data centers. We really appreciate your attendance today and your engagement during the webinar. Euralarm is leading a European association grouping fire, safety, and security industries. With webinars like this, we provide a platform for professionals to stay up to date with key topics which concern fire and security applications. We are structured into 4 sections. You can see the small icons in the slide. The first section essentially worked on fire extinguishing systems and applications and regulatory topics, excluding sprinklers. The second one focuses on electronic fire detection technologies. The third one, essentially the service section, focuses on maintenance and reporting of alarm services. And last but not least, our security section, which is essentially working on intrusion system, video system, everything that attains the security world and applications. Next one, please. Thank you. So in this slide, we see the role of the association. So we want to be essentially at the core of the key topics of the fire and security industry, talking to stakeholders into the fire and security industries, regulatory bodies, industry, but also, of course, the European community bodies like the European Parliament and the Commission. Especially now, we see a number of changes ranging through the regulatory scenario, updates on the CPR, updates on the legislative framework, the 1025. I think is very important to stay up to date with these topics, as well as whatever concerns vertical topics like digitalization. We provide guidance and support to our members to adopt these, enhancing technologies in a conscious and safe way, especially if you think about artificial intelligence and how we can apply artificial intelligence to fire and security products. Still, leveraging the benefit of this technology, but still remaining within the boundaries of the European regulation on the topic, cybersecurity, all of these. But also in the meantime, we are looking at reducing barriers and allow innovation to essentially being transferred across the internal borders of the European Union, and essentially fostering that innovation, especially into our solutions. We also look after, qualified and well-trained workforce. This webinar goes into that direction, but webinars are not the only activity we do with regards to education of the workforce. We publish guidance documents, white papers, we conduct trainings, and of course we keep an eye on the next generation. We have several initiatives in which we are committed to approach young professionals and inform them about the opportunities that the beautiful sector of fire and security can offer to the next generation of engineers and professionals. By the way, this week we will be attending Sicurezza in Milan, a fire and security exhibition in which we're going to address a speech directed to young professionals visiting the exhibition to explain them the trends we see, current and future trends, of course, we see from a technological perspective into our sectors, but also the great, work opportunity that they can find if they look at the fire and security market. Of course, the Green Deal, the Green Agenda in Europe is key, and we are a strong supporter of that. We contribute to the regulatory aspect, and of course we see that as an opportunity, but also, indirectly, if you think about it. For example, today we talk about fire protection and fire detection. If we can prevent a fire to happen, that's going to inevitably have a positive impact on the environment in terms of all the emissions of CO2 and chemicals that we can avoid if we can avoid or even contain the fire at the very early stages. Essentially, these are the key topics that our association focuses on. If you have additional questions, or if you are interested in joining our mission, please don't hesitate to reach out to me or to Martin. We will be extremely happy to provide you with additional information and guidance on how to join us and support the agenda that we drive across Europe. With that, I once again want to thank you all for attending today, and I'll hand the floor over to Chris for the webinar. Thank you very much.
Thank you, Martin. Thank you, Peter. Hello and welcome. My name is Chris Downing, and whilst I work for Johnson Controls, today I am wearing my Euralarm hat as I've been asked to give this webinar on the selection of fire protection systems which will focus on data centres, but the principles should be portable to other applications. I'll be using PowerPoint Live. Please may I ask you remain on mute and keep questions to the end. However, you can put messages in the chat and Martin will use those to kickstart the Q&A. We all know how much we depend on data. Instances like our favourite retailer falling foul of a ransomware attack, or the recent blips with AWS then Azure, remind us of this dependence. The physical damage and impact from fire is both immediate and relentless. Whilst building codes and fire regulations rightly prioritise human safety and limiting fire spread, they often have no regard for the consequence of downtime. So we, Euralarm, wanted to provide guidance on this to help facilitate meaningful stakeholder discussion addressing the gap between regulations focused on life safety and the need for operational continuity. Today, I will frame this development, our reasoning, and I look forward to a Q&A at the end. Euralarm has a number of sections, including, as Peter said, security, fire detection alarm, and extinguishing. I sit on the extinguishing section, which has somewhat over 30 members. We're a broad church with a mix of manufacturers, installers, system integrators, inspection, test and maintenance companies, as well as trade associations and testing laboratories and the likes. I tell you that because I want you to appreciate it is good and healthy, with us being prepared to robustly challenge one another. At every meeting, the section chair actively seeks input from members about the issues we face, and we always close with an AOB. Back in May 2024, one of the system integration companies raised an issue they had regarding misinformation and confusion in the marketplace. A task group of volunteers was formed comprising about 11 members. The initial scope was defined, but we then honed this from just broadly system selection to focus on data centers, as this was felt where the issue was most relevant, and a good data center comprises many of the attributes of a typical example. So it was a good thing to work from. Charlotte, who raised the issue, instigated and led the group, and I had great privilege in being part of that. It was only towards the end, when Charlotte took maternity leave, that I offered to help her across the line, hence me presenting this to you today. Credit must go to all the task group participants. I think they did a really good job, robustly challenging one another, culminating in this fine document. Once the task group had finished drafting it, it then got elevated to the whole section, who vetted, and once it was approved by them, went to the other sections, who also had chance to comment before final publication. We published in February 2025, and translations are available on the Euralarm website in German, Spanish, English, Dutch, and French. And I've provided links to those at the end of this presentation. So let's start that journey on what we decided and why. I said on slide 3 that building codes and fire regulations are typically predicated on the preservation of life, often with little or no regard to the consequence of downtime. So let's agree on some of my other language. I will use the term code as the regulations or rules in order to build or be allowed to open or then occupy a building. Good example, a building of this type must have that type of protection would be a high-rise residential building must have sprinkler protection. The standard then says how you set about the design of that system or the manufacture of those products. But we wanted to go deeper than that with this document. We wanted to consider the requirements not just of the code official, but of the wider stakeholder group to provide objective guidance that can be used when driving a roundtable discussion. In order to simplify the considerations, we opted for some emojis. Now, it's important to understand, an unhappy face does not necessarily mean a system or product will not work. It just means relative to the other technologies, there could be better options. So please keep this in mind when I go through these slides, as I discuss the tables, and when you use the actual guidance itself. I borrowed this visual from Dr. Julie Connolly. I really like it. We are all in the same storm, we're just in different ships. So what do I mean by that? We know fire is indiscriminate. It does not care if you're a hyperscale, in this case you could say the cruise liner, a co-location site, or you're an enterprise with your own on-premises data center. So think of the ships as the data center, the client, and the fire as the storm. But what is the purpose of the ship? Who else is on board, and how are they each affected, and what do they require? So that's a question of impact and resilience, and that's really about what we're looking at. Another piece of language I will use, and AI gave me the translation for this, is the white space and grey space. The white space, supposedly named after the colour of floor tile used, is the operational heart, the brain inside the data centre. This is where the crucial operations happen. It sucks in power, crunches ones and noughts, and liberates its responses along with a lot of heat. We also have the grey space, supposedly the grey floor tiles or lino, which is the plant and support areas. These grey spaces might benefit from dual feeds if it's a higher tier, so could have some inherent redundancy. Let's now consider what all this means in terms of fire. I'd like you to remember this fire growth curve as we're going to challenge it. In the white space, we expect an incipient stage of fire growth. Something goes wrong, leading to an overheat. In still air, you're likely to smell this before we see it, and when we see it, it will start most likely grey-white smoke turning darker over time. I say it's a curve, and it only takes that shape when we get to the stage of flaming combustion. Once fire breaks out, we see rapid growth, often exponential, and with the flames and fire growth comes havoc and destruction. Fancy words for interruption and disruption. Now stir in some cooling. How does that affect fire growth as well as a means of detection? I'll pause and let you think about that for a second. Detection. Detection can also mean, if we have a glass bulb that is thermally operated, think sprinkler head or water mist nozzle, and if the purpose of the airflow, the air conditioning, the cooling, is to strip heat from a processor to prevent it overheating and it suffering thermal damage, we have a conundrum where the same airflow will impact any fire development from operating a thermal bulb. Let's flip this now and we'll move from the white space to the grey space to a diesel generator where a hose could burst and the resulting fuel be sprayed on a hot manifold. There's likely to be instantaneous heat, flames and fire, and loads of it, no incipient stage. So we wrote the guidance to use a data center as an example, recognizing the points raised will apply to other applications where similar conditions prevail. What will burn? How does that start and grow? And how best to intervene and to end it? More regarding the language used, and we've touched on detection, but what about active protection? So first, let's look at fire control. This is systems such as sprinklers, which release water onto the affected area to control growth. They pre-wet combustibles. These systems are very effective at containing fires and preventing their spread, and in some cases, they may even result in extinguishing where there is adequate flow and no shielding. Next, we have suppression. Think systems like water mist, effectively reducing the fire intensity. The suppression is a reduction in heat output, or you could say an increase in localized heat consumption, but that's reliant on the water mist getting to the seat of the fire. Noteworthy there, suppression systems typically have a minimum runtime, and that's to provide control and suppression until the fire and rescue service, the fire department or fire brigade, depending on your language, for them to arrive and get in, and for the firefighters to achieve final manual extinguishment. Fire extinguishing systems, exemplified by gaseous technologies, do extinguish. They're highly effective and leave no residue, which makes them suitable for use in sensitive environments and where full cover is necessary, i.e. extinguishment penetration of the IT equipment so that the business can operate, possibly uninterrupted, but that comes at a cost. So let's effectively thumb through the document. We'll start with section 4.4 of the guidance, which sets out a sequence of events. We start on the premise that a detector has gone into alarm. In the white space, this is likely to be an aspirating smoke detector. For plant areas, it might be a normal point type device. What next? Can security validate the alarm using CCTV? Now that doesn't need to be on site, that could be remote. Do we flag this to IT if it's in the white space so they can interrogate their systems in that area to pinpoint the cause and precise location of the asset causing the alarm? That too can be remote. Remote identification and shutdown of that offending asset could resolve the whole issue. Do we mobilize the on-site team if you have one? Are they allowed to approach an alarm? And I do mean this. Do you have standard operating procedures that allow them to do that? Do we assist their approach, perhaps opening specific doors or weakening other security impediments, because inherently a data center is impenetrable? Site first responders identifying the asset in question and locally shutting that off might work. Literally hit the power button. But if it's ready to burn, we in theory completed the fire triangle, but the localized fan was keeping that at bay, stopping that local fan might actually trigger the flames. Having your first responders competent and equipped with a portable extinguisher thus makes sense, sound sense. But on the flip, could use of a portable fool the detection system into thinking the situation has rapidly got worse? They could, or arguably should, put the system in the manual mode of operation when they're taking control of the situation. It's rare to ever hear me say that. I am a stalwart behind keeping systems in their automatic mode, but in this case, that would make sense. And it needs that level of detail thought out, documented, written, and understood. And I'd say actually run through, get them to try it and ingrain it. For example, if first responders can't get there, or if the fire's grown too large, or it's too great a risk to leave unaddressed, then automatic extinguishing might be necessary, automatically or manually deployed sooner. This could also be prophylactic, and by that I mean the system deployment prior to flaming combustion to ensure there is never flaming combustion. As we go across to the most right hand side of the slide, the last stop, we have sprinklers or water mist, which we must appreciate is not automatic extinguishing, it is suppression or control, and requires the heat bulb to operate. Furthermore, that type of system might necessitate the fire detection slowing or stilling the airflow, which might not suit other operations. Also, use of water will likely necessitate the removal of all power, and most IT dislikes abrupt power removal. With so many conflicting ideas and points thrown at you, let's now pick that apart. The guidance sets this picture and considers each stage of system use, commencing with business as usual. What's it like to live with the system in its quiet, calm, quiescent mode? We then walk through the stages of escalation, though some, as exampled earlier, might not apply. Remember, I asked you to challenge me on the fire growth. The example, diesel doesn't smoulder. You might not have an incipient stage. You can skip that. We take these steps through to conclusion if you have a water-based solution, sprinkler or mist, providing control or suppression that still needs final extinguishment by someone. Normally, that's your fire department, your fire brigade, the fire and rescue service. Let's think about that for a moment. If you have a rack of cabinets, one of which is on fire, to a sprinkler system, that rack may as well be an umbrella. Water mist might fare better in suppression, but both are unlikely to fully extinguish. Is the full rack an acceptable loss? Maybe that needs to expand and be the full row being written off. For some, this is a likely yes. For others, maybe not. Those water-based systems might also need slowing of the airspeed, as I mentioned earlier, to be able to work. For example, water mist, if that needs less than 1.5 meters per second, which to some of the world is a smidge over 3 miles per hour maximum airspeed. Can you live with that? And is the system set to achieve it? What about over time, with plant and equipment changes or service and operational tweaks? The required deceleration could easily be removed and then the system unable to perform as expected. If using water, how abruptly must the power be removed? And what's the impact of that? If the fire brigade, the fire department, are required to achieve manual extinguishment, what are their needs and the likely effect of their actions? I suspect they will require all power to be removed from within the protected space. Don't forget, if we have not put the fire out, it's continued to burn, continue to make smoke, and that will obscure vision, as well as the consequence of smoke contamination itself. Now we understand the task group reasoning, let's look at the output. And this is section 5. It starts with a high-level overview, and we've tried to be objective. You can see here there is no one-size-fits-all answer. That said, this should help a stakeholder group establish what they are willing to accept as a compromise, say, if they want a site-wide approach, or perhaps opt for a main concept and supplement that with what is needed for a specific risk, e.g. sprinkler the whole building, but for the critical areas, have gas as well. Section 6 of the guidance is the deep dive for the stages of fire growth. We did not differentiate the white or grey space in the guidance. It's for the user to apply the pros and cons to their requirements for their specific application. We hope the pros and cons will help them in reaching an informed opinion on what they want, understanding why they chose that too. So let's power through a few of those, more to spark curiosity for what I hope will be an engaging Q&A session at the end. Starting with business as usual. I speak from experience where a client had an oxygen reduction system for their grey space. Initially this seemed great, but their safe system of work meant each plant patrol, and that was 2 times per day, required 2 people instead of 1. Due to the low oxygen, they had the plant inspecting technician accompanied by a banksman who stood in the doorway with the door held open. Not only was that double the labour cost, but the door being open caused a compromise to protection. Furthermore, restoring the protection drank loads of electricity, which was an appreciable sum. Added to this, when works were planned in the area, major works, full oxygen was restored, and so after works, when fire is possibly of greatest likelihood, there was a period of no protection until the system was able to get down to the target oxygen level. That's just one example. Next step, the first in fire, an incipient fire. Think a component failure in the white space. There's no heat, so sprinklers can't operate. Deluge water mist could, if detector triggered, but that has wide-reaching consequences. A gas system could prevent this escalating to flaming fire, so far better, and an oxygen reduction system would prevent it, presuming you're at the right residual oxygen level. Next, we progress on to a flaming fire. The situation in the white space has escalated, or perhaps it's a plant room where the combustible has faster fire growth. Think of a containerized diesel genset, a Class B. Water mist loves this, as does a condensed aerosol. We try to give a suitability smiley, but have provided more nuanced information in the pros and cons. We discuss system deployment. My personal viewpoint is that inert gas systems are fantastic at protecting the white space of data centers, but the risk of noise affecting hard disk drives is grossly underappreciated by the data center community. Those tight NDAs are doing nothing to sharing lessons learned. So, the side takeaway from today is that if you have an inert gas system protecting anything with hard disk drives, you need to have acoustic nozzles fitted. or retrofitted. The key standards now flag this issue, but to my knowledge, none make it a retrospective requirement, and I fear many service providers, those are ITM contractors, aren't necessarily aware of the issue themselves, nor suitably flagging it. Next, we consider the fire department intervention. It might be the case, subject to your choice of system and the authority having jurisdiction allowing, you need not invoke a fire and rescue service response, or they attend, but physically you do not need them to go in, or you prevent them going in. Consider this: interrogation of the IT system, you identify the offending item, you remotely shut this down, and all of this has been done in an atmosphere that prevented the outbreak of fire. You've got a good hold time, and cooling of the offending item has happened long before the hold time is lost. That's great. That's business as usual, uninterrupted. And I think as we move towards more edge sites, perhaps in unmanned locations, this will become more of a business necessity than just shrewd planning. We do not ignore the aftermath. Aside of the oxygen reduction systems, all of the other fire protection systems will need some actions before protection is reinstated. That consisting of system recharge as well as possible cleanup. Now we're approaching the end, and I hope this has sparked some good questions. Earlier I said there is no one size fits all, but for you there might be. It is down to your specific needs. Remember, this is not about blind compliance, it's about proper oversight. I encourage you all to not just look forward, but review what is existing and consider possible tactical as well as operational changes. I like to believe a good design needs to not only perform today, but be flexible, be adaptable for the future. What that looks like, I cannot say. My crystal ball is pretty hopeless. It is, however, imperative that any change in use made in the protected area gets flagged to the fire system service provider, ideally early on when designing the change in use. Fundamentally, what burns, what is produced when burning, incipient and through fire growth, and how that is detected remains fundamental. Other changes could also impact the efficacy of the installed system. For example, immersion cooling is an area I'm watching with genuine curiosity. At the back of the guidance, we have provided further information. You can see the sources reference that we have used. For example, this builds upon the likes of EN 5600 parts 2.5. And note it was published before VDS published their 6003, hence that not being cited, but I'm pleased to say they very much align with our reasoning. I like what the Fire Industry Association in the UK wrote about detection in high airflow environments. The FIA also worked with the American Fire Suppression Systems Association, the FSSA, to explore the impact on gaseous protection of continued cooling, high airflow and aisle containment. And Euralarm has put a document to discuss this too. So that brings me to the end of the guidance and the end of these slides. Please remember, our goal is not to give you all the answers, but provide you with the insights to better equip you to ask the right questions with rigor and to robustly challenge all the reasoning. We will now go to the Q&A. This screen here shows how you can access the guidance in English and all those other languages. I'll now pass the microphone back to Martin, our moderator for your questions, and I thank you for listening to me. Martin.
Thank you, Chris. And as promised at the start of the webinar, and as you already said, it's now time for some questions and answers. If you have any questions, drop them in the chat or the Q&A, but may I do the opening, Chris, by asking, have you encountered a situation where a fire protection system failed or underperformed? And perhaps more important, what were the lessons learned?
Oh, wow, that's a doozy of a question. All right. I don't like it when people say that's a good question, but in this case, it is one. I think where there have been failings, those will be tied up in legal cases. It'd be wrong to write against them. The FIA has written a good paper about time delays. So going back to that timeline, I think for people to consider what's going to go into alarm, who's going to respond, how long do they need? Those are some pretty simple questions. Other failings, I would say, inert gases have been time proven. We've been using them in the market commercially, I'm going to say since the 1970s or 1980s. So they are well established. You can liken it to an incandescent light bulb. The atmosphere in the data center will prevent a fire, but it doesn't stop something getting too hot. It was about 2007-ish that the technology in hard disk drives came forward. So for failings, I would say hard disk drives, a lot of people have inert gas systems and hard disk drives. If that system is deployed, there is a high likelihood, I would say, that it could corrupt, damage, or data within the drive. So I think that's something the industry needs to pay better attention to, or try and raise the profile of.
Okay, thank you. A question came in. Can you explain which one is effective, whether FM200 or Novotec 1230 gas for data centers? I'm not sure if you're... can you answer that, Chris?
I can. I'll try and bring it to context for people who are less familiar. Within the gaseous technologies, we can either use an inert gas system that drops the oxygen level, or we can stir in a chemical that effectively extinguishes by other means. So the two technologies there, FM200 is a brand name for HFC 227. Novec 1230 is a brand name for FK5112. They're both an additive to air. I would say used at the correct concentration, both do their job. Now, if we think of that timeline, the fire tests are always against a pretty serious fire, a wood crib for the main extinguishing concentration, and then perimeter tests, there'll be test cans. Ideally, we deploy these gases early into the fire growth stage, ideally before we actually have flaming combustion, but I would say a well-engineered system for both of those, they should perform pretty well the same, unless you go in there and sniff it and think, oh, this tastes different. If you showed me a video, I would probably struggle to tell you which of the two it was.
Okay. One more question. How do you propose to provide a specialized team whose sole purpose is to respond to an emergency situation? It's a big decision to send people into fire. And I think that you will also agree. Yeah.
It's a valid point, and I like people asking me that. So let me just see if I can jump us back to this slide here. So if you can see the slide at the moment that has the fire growth curve on it, and a lot of this has come from physical experience on a site. So we have to presume here, if I try and turn on the laser pointer, the sprinklers are the last resort to prevent fire going into adjoining areas and also to safeguard the building. Before that, we've got a total flooding gaseous system. If so, that should be designed for most applications at a human safe concentration. But we're trying to get in at this level, and at this level you could say, is it actually a fire, or is it an event that ultimately will grow to a fire? So I think to have a few elite, if I can say that, so like you have a fire warden sweep through the building checking people have evacuated, your first responders should be notified of an early alarm and able to go in. So we used here imagery to say, could CCTV assist them? IT can remotely dial in, but can we warn them? Can we send them in? Can we even unlock doors for them? I think unlocking doors is an unrealistic ask. I'm picturing George Clooney in an Ocean's film, dressed as a fire service engineer, triggering an alarm and walking straight into a data center. But for them to go in with a portable extinguisher, able to catch it at this stage, could be far less disruptive than waiting for the fire to grow. So I think that will go down to the authority having jurisdiction and what you're allowed to do. I think in the Americas, I'm trying to think what clause it is. I'm fairly sure there's a clause in NFPA, and I want to say 75 or 76, that even talks about very early warning fire detection, saying in those cases you can go in. But that would be something that the operator needs to agree with the on-site team, be that FM. Certainly, I think asking people to enter a gaseous protected area, unless the door they've got to go through has glass panes in it so they can see that they're not walking into a fire, or there's not walkie-talkies with CCTV, that would be a risky ask. But I think for most areas, the doors, most data centers I've been to, the doors have a glass viewing pane in. So any first responder, before they walk into the area in alarm, can immediately see, is it smoke logged or not? If it's glowing yellow, orange and red, you don't go in. And that would be the case that if there is a system to manually deploy it sooner.
Another question, Chris. Compared to clean agent, inert gas need more storage area and cylinders. Is that a disadvantage?
It can be. So the two products I spoke of earlier, the one that reduces the oxygen takes about 3 times the footprint of the chemical additive, but it can flow a lot further. So for big data centers where you have multi areas, you can then start to say, well, I need a bank sized for the largest area, and I will then use a valve to send it to the appropriate room that needs it. In some cases, that footprint is critical, is either not available or it's very expensive. In other cases, you may say, hey, I'm building a small modular reactor next door. This data center's in the middle of nowhere, I can do that. And that raises an important point. If we're going to build these in far more remote locations, having an automatic system and an on-site crew that means we're not reliant on the fire and rescue service, I think is very, very important.
Okay. Another question, are data centers concerned about the environmental impact of gases like FM200 and Novotec 1230, especially considering their GWP and potential regulatory phase-outs?
I would hope that everybody considering building a data center is doing the very best they can for the environment. Yes, the synthetic agents, when released, will have an effect on the environment. Arguably, the impact of that should be far less than an uncontrolled fire. So I think we need to bring that into perspective. In some countries, you may not be allowed to have those systems. I think throughout Europe now, if you have a 227 and FM200 system, you're able to maintain it. I'm not aware of us putting in any new systems. Novec 1230 or FK 5112 has greener attributes in global warming terms. I think it's got a GWP equivalent of 1. But in many cases, there will be the full calculation of the embodied carbon, the footprint, the storage, and all that sort of thing.
Relating to that, clean agents, FM200 and FK 5112 are ozone, zero ozone depletion potential. Is that correct?
Yes, both of these have. So if we look at everything we're trying to achieve on the environment, we started worried about the ozone. Before that, we all used Halon. Fantastic product. Had we been better taking care of it, we might still be allowed it. Anyway, so we moved to zero ozone depletion products, but all of these products have a global warming potential. Now, as we're starting to see on the green agenda, we're now not starting to look at not just what happens when it's emitted, but what's the environmental impact of having a system over its life cycle. I think that's going to be some interesting maths. And that may help a data center if they want to say, well, actually, the embodied carbon of this is preferable. I think what we're not doing yet, which I think is a shame, is saying for this application, what is the likelihood of a fire, and then factoring that in that decision making as well.
Okay. A little bit different question. What factors should be considered when integrating fire protection systems with building management and monitoring platforms, Chris?
An exciting space. The future, I think, will be brilliant. At the moment, a lot of those systems are standalone and isolated. I think there's good potential to automate the workflow in there. So even if we try and keep them as disparate systems, we could say, right, when an alarm comes in this space, does it automate a workflow? The example there, the CCTV, instead of just being wide area. So I think if I can answer the question there to say, there's an exciting future. And the great thing about Euralarm and the trade associations is trying to be a part of that, to shape it, to say, what is possible? How do we encourage adoption of that in the market, but in a safe and secure way, rather than a reckless way of thinking, oh, I think this could be possible, and then we find out that it's fallible.
Okay, thank you. Are there any segregation or separation distances, rules, or requirements for spread of fire in data centers, Chris?
Ooh, that sounds something outside my control. That sounds like a passive fire protection side of things, where how big a compartment can I build? Now, with protection systems, the smaller the compartment, the better, because the less consequence if there's ever a system deployed. I'm not sure around the world. In some countries, there may be trades made. For example, we want this wall here to be 2-hour fire rated. However, if either side of it has sprinkler protection, you can drop that construction down to 30 minutes or something. So I think that might be the answer, but I'm afraid I'm not able to give you the specifics. And that is where going to an in-country expert is invaluable.
Okay. I think that we are near the end. One more. Are the new technology of hard disks really sensitive? The noise made by gas extinguishing systems.
So if we're talking hard drives, solid state drives seem impervious, or I've yet to hear news of them being fallible. The problem with the data center community is it was probably about 2011 that we started to hear of the first instances of a system being deployed and a hard disk drive falling over or suffering. So we are, as a manufacturer, sadly, somewhat blind and deaf to what's going on out there. And that's because when an incident happens in a site, unless it affects the world or it's publicly known, it's wrapped up tightly in secrecy and NDAs. But I would say, if you have hard disk drives and you've got an inert gas, I would say there is high probability, but it's very easy to retrofit acoustic nozzles to a system. It doesn't need to cost an arm and a leg.
Okay. I think that's it, Chris. There are no questions left.
If I may, I've got the chat open. I see there's one that's popped up, the penultimate one, from Harmbotta. The question you ask about PFAS and ECHA is an exciting time. The dust has not settled, and we won't know the full final outcome. There's still a consultation to go from the socioeconomic committee's outputs. But I would signpost you, if you go to the Euralarm website, in the handy search bar up top, if you type PFAS, there is guidance provided by some great people, chemists and the likes, way above my scale, in the extinguishing section. I think it's version 7 of the guidance gives you the latest. So answering your specific question on that, there is some really great guidance within the Euralarm website.
Okay, and once we have said that, it was the last
I'm not in
question.
a
The
rush.
new questions are dropping in. Chris, how does the
Good.
introduction of high-density liquid-cooled racks affect your choice between pre-action mist systems and clean agent systems?
It's a brilliant question, and I'm going to break it down into simple, small segments. And this is my opinion, thinking, and remember, I'm wearing a Euralarm hat here, not Tyco, Ansell, Johnson Controls. If you're going to go to liquid cooling, that is going to strip away a lot of the heat from a processor. I'm going to say, great, that's waste heat dealt with however you want to. If you're going to change the way air moves, do we still have detection located at the right places and set to the right sensitivity? So if I have aspirating detection set for 10 meters per second airspeed, but you change the cooling, will products of combustion still get to the detector? And with a change in airspeed, that could change how diluted it is. So I think you need to ask yourself those fundamentals. Liquid cooled racks depends on the coolant. If you have a hydrocarbon based dielectric, that's different from just a direct to chip cooling system. I think if we go hydrocarbon, that may be the time that we start to say, I'm worried about a bigger fire, a quick, fast flaming fire. And that's where water mist and sprinklers certainly would look good. And I think when we go to immersion tanks, that's when you've got to say it's a totally different beast now. And that's where water mist would probably be better than a clean agent. But today, if you've got racks with air movement, I'm still very much a fan of, as that slide shows there, inert gases doing their jobs or a chemical agent. And then a sprinkler system is the last resort to safeguard the building, and it may be a requirement by the local authority or your insurer.
Okay, Chris, one more. Do you see a rise in converted data centers as opposed to purpose-built? And what challenges does that present?
I don't get out of my office enough, so I need to get out and see some more data centers. I think in any case, it's a structure, and we're putting in it a lot of combustibles, the electronics, the cabling, and the likes. And I would say for a lot of data centers, you may even argue the contents of the rack is less important now than the cabling and the infrastructure feeding it. You can replace a rack item a lot easier than you can if you damage a lot of cables. I suspect at the moment we've seen a lot of people move into, well, I'll just sprinkler protect. If it's good enough for the hyperscales, hey, they're clever, I'll do the same, without thinking about their might and resource. I think as we start to move to more resilient systems that are less dependent on the fire and rescue service, I think we're going to see the pendulum swing back and more demand for gaseous systems. And I'll give you a for example. Say you've got a data center, and it doesn't matter whether it was purpose built or you've put a box inside an old factory unit. Well, if that was Los Angeles back in January, middle of January this year, the Palisade fires, the fire department were overwhelmed. They had their work cut out for them. That if you phoned up and said, my data center's on fire, help, can you do something? And I think we're going to see more of that. We build data centers that are inherently impenetrable. So to have a system that is itself self-fulfilling, self-protecting, not reliant on others, we don't need the fire department to turn up. We don't want them adrenaline charge going in with hoses. I think that's where we're going to see more people map out in their procedures what's on screen now and say, that's what we expect. How often do we drill it? How often do we take the first responders through a scenario? Do we surprise them with that? Let's see and check they can still do what we expect them to.
Okay, Chris, thank you. I don't see any more questions. With no questions left, I think that the time has come to close this session. First of all, I would like... Sorry, Ken.
I was just going to say thank you to everybody for giving me your time. Sorry I've had to drink so much. I'm afraid a cold has got a grip on me. Martin,
Okay.
Would you like to wrap up and close?
Okay, thank you, Chris. I would like to thank you all for attending this webinar. Special thanks to you, Chris, for your contribution, and to Peter Mita for your information, the recordings of this webinar, as well as the slide that will be available soon via our website. And if you're interested in the latest news in fire safety and security, I recommend you to follow Euralarm via LinkedIn, visit our website on a regular basis, or simply subscribe to our newsletter. And with that, I would thank you all and say goodbye, and hope to welcome you next time with one of the Euralarm webinars. Thank you, Chris. Thank you, audience.
Thank you.
See you soon.
Thanks all.